Hello, welcome back. Today we're going to look at another way of solving percent change problems, and we'll use our calculator to help us on those, although you could use it even without your calculator. But before we do, everybody knows the story of Noah, right? The flood was coming, he had to get all the animals onto the ark, and that took a long time. There were a lot of animals coming, a lot of them moved really slow. Imagine how long he had to wait for the sloths to get on the ark. So it took a while to load up that ark, and obviously he couldn't get it all done during the day. He kept going at night because he knew the rain was coming. So what did Noah use to see in the dark? Once it got dark, he needed to see the animals coming, make sure they wanted to. What did he use to see in the dark? So let's talk about percent change using multipliers. So let's look back at this type of problem we've already done before. Increase 250 by 15%. So how did we use to solve this problem? Well, we could work out 15% of 250, which was 0.15 times 250. Now, right now we're just going to use our calculator, but if we're doing this without a calculator, right, we could do the old way. We could work out 10%, which is 25, and 5% is half of that, which is 12.5. So 15% is 37.5, right? That's how we would have worked out 15% if we didn't have a calculator. So with our calculator, we're just going to do 0.15 times 250, and that's going to give me 37.5. Now I want to increase 250 by 15%. So I've already started with 250, okay? And I want to increase it by 15%. So let's look at this. 250 is 100%, isn't it? That's the original number. 37.5 is 15%. Okay, and I add them together, and my answer would be 287.5, which is 115%. Okay, my original number was 250, then 287.5 is 115% because I increased by 15%. Well, we find a percentage, don't we, by changing the percent to a decimal, don't we? Look over here, 15%, I changed it to a decimal by dividing by 100. So I can do the same thing over here. 115%, what's 115% as a decimal? As a decimal, it's 1.15. So check out this shortcut, really powerful. We're going to use this a lot. If I want to increase 250 by 15%, what I'm really asking is, what is 115% of 250? What is 115%, which as a decimal is 1.15? And again, with our calculator, we put that in a calculator, 250 times 1.15, and we would get our answer of 287.5. Look how quick and short that is to solve this problem. Increase 250. Look at all the rest of this work we've done there. We can do it in one line of working out. If I'm increasing it by 15%, I want to know what 115% is. Okay, so let's try another one here, right? Increase 70 by 15%. Well, again, we could work out 15% of 70, which is 0.15 times 70. Okay, again, we could do it the old way, right? Nice little review because we need to know it both ways. 10% is 7, 5% is 3.5, 15% is 10.5. Okay, so, but again, we're going to be using our calculator, so 0.15 times 70 is 10.5. Okay, and I need to add that to 70 because I'm increasing, so it's 70 plus. Now again, look at this. 70 is 100%. That's my original. 10.5 is 15%. If I add these up, I get 115%. I add them up, I get 80.5, which is the same thing as 115%. So the one calculation I can do instead, 100%, which is 70, right? 70 is 100%. Increase it by 15%, I have 115% of 70. And 115% as a decimal is 1.15 times 70. Check it. If you don't trust me, in your calculator, you're going to get 80.5. Again, this is the only line right here in red. That's the only line of working. If you're using your calculator, you need to show. You need to write it down. You're going to put it in your calculator. You've got to show you're working. That's what you're going to write down. Now, what about for decrease? If I want to decrease 5.2 by 40%. So again, the old way, right, we would work out 40% of 5.2, which is 0.4 times 5.2. Again, put it in our calculator. 0.4 times 5.2, right, is 2.08. Okay, that is 40%. Okay, and then what did we do? We needed to, I started with 5.2, which is 100%. And how did we solve this? I want to decrease by 40%. So we're subtracting, aren't we? We're going to subtract 5.2 minus 2.08 gives me 3.12. What's 100% minus 40% is 60%. So if I start with 100%, which is my original, I decrease it by 40%, I'm left with 60%. So that's my multiplier. So how can I do a multiplier of this? All right, decrease 5.2, 5.2 times, if I decrease it by 40%, I'm left with 60%. I want to know what is 60% of 5.2. So be a little bit careful. It's a little bit trickier on the decrease problems. And if I put that in my calculator, I should end up with 3.12. Okay. So on an increase, I add the percent to my 100%. On a decrease, I subtract the percent from 100%. Again, in red, that is the only line of working you need to write down if this were the problem. Okay, so let's go straight to using a multiplier. Decrease 24 by 20%. If I take away 20%, what's left? 80%. So I just need to do 24 times 0.8. Okay, this number 0.8, this is our multiplier. That's what we call these. We call a multiplier. Sound familiar? Okay, so I'm just going to do this. Again, this is the working out I'm going to write down. I'm going to put it in my calculator. 24 times 0.8 is 19.2. If you compare this to the problems we did in our old module or non-calculator module, much quicker. Multipliers are a very powerful tool. All right, let's look at one. Decrease 42 by 7%. If I decrease by 7%, what do I have left? 93%. So I want to know what is 93% of 42. Write down your working out before you put it in your calculator. 42 times 0.93 equals 39.06. Okay, look how quick. Multipliers are extremely powerful tools to work out percent change problems. Very powerful tools. So this 0.93, that is what we call our multiplier. Okay, so that's how to use multipliers. You'll have a chance to do some practice. Before we do, Noah's loading the ark. It's getting dark. How is he going to see in the dark? Well, of course, he used floodlights.